Hi friends, today we are going to solve an MCQ. Let me read the question. Resilience is best defined by which of the following? So the options are amount of energy absorbed within the proportional limit, stiffness in stress strain graph, quality of material to come back to its original state after removal of force supplied. This is partially correct. Modulus of elasticity. So the answer here is amount of energy absorbed within the proportional limit. So first of all, what is proportional limit? Proportional limit is, here you can see this picture, you can see the proportional limit. So this kind of material where this portion is called the proportional limit. Why? Because whenever the material is in this position, it can come back to its original shape without any permanent deformation. Permanent deformation is like a leaving a small kind of deformed bend over the surface of the metal. So that kind of bends will not be present in the case of metal when it's within the proportional limit. So that is proportional limit. So let's come back to the question. So that in that proportional limit region, the amount of energy which is absorbed, that is equal to resilience. That is, in this diagram, in the shaded region, the amount of energy which is absorbed, that is called resilience. So here the amount of energy absorbed per unit volume when the material is being stressed to its proportional limit is called resilience. So this is the definition of resilience. So why it's not stiffness? Stiffness is the whole region. We show you in the different color. This whole region is stiffness or toughness. So there is difference between stiffness or toughness and proportional limit. So what is modulus of resilience? Modulus of resilience is the amount of stress absorbed without permanent deformation. That is, it doesn't undergo a permanent deformation. So the amount of stress absorbed in that period of time is the modulus of resilience. So to explain the permanent deformation, let's see here. There is a wire like this. So I am bending it with more amount of force, like this. I am bending it and it's becoming like this. Okay, so it has gone beyond its limit, that is, it has gone too much. So when I am trying to pull it back and I am giving force like this and I am trying to pull it back, it won't come like this like before. No, it would come like somewhere like this. So this is the permanent deformation which is spoken here. So resilience in simple terms is springiness, that is the kind of how it comes back to its original position without a permanent deformation is the resilience. And let me show another picture here. we are having the proportional limit somewhere around here, and yield strength is the particular amount of strength which the material will have where there will be a mild deformation, like which I told in the example here. So here it is a mild deformation. So whenever it goes beyond the yield strength, there is going to be a mild deformation. But within the proportional limit, it's going to be completely elastic. It's going to be totally normal. So here we have the elastic deformation, and here we have the plastic region, and then when it goes more than the plastic region, it's going to be necking, that is non-uniform plastic deformation, that is there is going to be more deformation, and ultimately there is going to be a fracture. So that is called ultimate tensile strength. Ultimate tensile strength is the highest strength where there is going to be fracture beyond the particular limit. So with this, the last picture here, toughness is overall portion is toughness. So ultimately after toughness there is going to be fracture, but resilience is, here is the difference. So there is, this regions are not covered, only the elastic region is covered, that is without any permanent deformation or mild deformation, it's going to be completely elastic. So these diagrams are very important, and if you are going to write a short notes, these diagrams have to be driven. Otherwise, to understand this MCQ, it's more than sufficient. I hope you understood the video. Let me know if you have any doubts in the comment section. Thank you.